The process of looking at the last term, one thing you might want to look at is something called boundedness. And in order to look at boundedness, it really helps to know if something is always increasing or always decreasing. And so we can do that algebraically very simply, is if everything is getting smaller, how would these two compare? Well, we have u of n greater than or equal to u of n plus 1. So we could say that u of n plus 1 minus u of n is what to 0? Less than 0, right? So decreasing is just u of n plus 1 minus u of n. The next term minus the previous one is going to be less than 0. What do you think it's going to be for increasing? Well, now you have u of n less than u of n plus 1. And if you go u of n plus 1 minus u of n, you can see that u of n plus 1 minus u of n is going to be greater than 0. So for increasing, it's u of n plus 1 minus u of n is going to be, what did I say? Greater than 0 or equal. I think they have an equal in there. Okay, so that's for increasing. Strictly monotonic or strictly increasing, monotonic means it's always doing the same thing. Always doing the same thing. Now we lose those minus signs. And it's just greater than 0 and less than 0. Monotonic means it's all increasing or all decreasing. Why would we want to know that? Why would we want to know if it's always increasing? Well, eventually, at infinity, what would it tell you? What the high value is. If it's always decreasing at infinity, what will that tell you? What the low value is. Maybe it's 0. So monotonic is a huge thing. U of n plus 1 minus u of n. Algebraically, when you find it, you decide which one of these to 0 it is. If it's always less than, you know it's decreasing. If it's always greater than, it's going to be increasing. It is not fun algebraically. Get ready with your fraction tools. You're going to be doing a lot of fraction work. Boundedness is a two-step process. You're going to check for increasing and decreasing, and then all you do is check the first and check the last. And what's the last usually going to be? The limit as n approaches what for the last? Infinity of u of n. That's usually what the last is. What's the first usually going to be? Yeah, it's going to be u of 1. Could be u of 0 or u of 2, but it's usually u of 1. Okay? Every bounded monotonic sequence converges. What that means is if it's always increasing and it has a high and it has a low, we can say that it's bounded by this high. Or if it's always decreasing and it stays at a value, it's bounded at its low. So strictly, if it's monotonic, bounded monotonics converge, and we want that a lot. So let's do one. And once you see this, I'll just turn you loose on a bunch of problems. There's the u of n. U of n is equal to 2n minus 1 over 3n plus 2. What's un plus 1 algebraically? Turn to your neighbor. Tell them what that is. So what you do is you put in an n plus 1. That's what we did. Minus 1. 3 times n plus 1 plus 2. 2n plus 2 minus 1 is plus 1. Yep. And 3n plus 3 plus 2 will be plus 5. Okay? So we do that first. Then you just check to see if it's increasing or decreasing. I think it's going to be increasing. That's my guess. Let's see if I'm right. So you go u of n plus 1 minus u of n. And that's going to be 2n plus 1 over 3n plus 5 minus 2n minus 1 over 3n plus 2. Are those denominators the same? Of course not. So we're going to have to make them the same. 3n plus 5 needs to be multiplied by 3n plus 2. Top and bottom because we're multiplying by 1. 3n plus 2 has to be multiplied by 3n plus 5. Top and bottom because it's like multiplying by 1. Then we're going to multiply this out. 2n times 3n is 6n squared. 3n plus 4n is 7n plus 1 times 2 is 2. And then here you have 2n times 3n will be minus 6n squared. Negative 3n plus 10n is 7n, but it's the opposite, minus 7n. And then, is that one important? We'll see. Then it's negative 1 times 5 is negative 5, but the opposite of negative 5 is plus 5. Is it okay that I distributed? Is that all right? Okay. I could have done an extra step. I'm lazy. I'm inefficient. So what cancels out? If you did this right, the 6n squareds had better cancel, and the 7n had better cancel. And so you're left with 2 plus 5 is 7 over 3n plus 5 times 3n plus 2. And you have to make the decision, what is that to 0? Well, n is going to be greater than or equal to 1. We're going to start with 1 and go to infinity. If n is a 1, is there any way this denominator will ever be negative? Will the numerator ever be negative? Nope. Positive over positive is always going to be greater than 0. Always positive means what? Means always increasing, yep. Another way you could do this is take the derivative, see if it's always positive. But this is a surefire way to do it. So what we proved here, we want to show that it's bounded, but first thing we showed is that it's always increasing. The other thing I need to do is check to see what happens at n equal to 1 and n equal to approaching infinity. Okay, so for n equal to 1, put it in the original equation, 2 times 1 minus 1 over 3 times 1 plus 2 is 2 minus 1 is 1 over 5. This is my, apparently, low, because it's increasing, right? What's the limit as n approaches infinity of, what was that, 2n plus 1 over 3n plus 5. What's that going to be? You can just, on sight, greatest exponent is first, so it's just going to be 2/3, right? This is going to be my high. This is going to be my low. Okay. Therefore, since u of n always increases from, what's my low? 1/5 to 2/3. The series is bounded by definition. Again, I stated what I knew. I knew it always increased. I went from 1/5 to 2/3. That increases. Series is therefore bounded by definition. And that's it. That's how you do it. That's how you prove bounded.